Okay, this is the P4 paper from January 2023. It's question number 5, and if we look at it, we can see this is going to be differentiation, finding dy by dx, and in particular, this is going to be implicit differentiation. Okay, so if we start off part A, y squared is equal to 2x squared plus 15x plus 10y, and they say find dy by dx. So if I'm looking at my function here, the y squared is going to be implicit differentiation, the 10y is going to be implicit differentiation. Those two you'd be able to do anyway, but let's go through and do it. So hopefully you remember, done enough revision to say, when I'm differentiating a y function, differentiate it would you normally, so multiply by the power, take one off the power. I would imagine you know that the differential of x squared is 2x. So differential of y squared is 2y, but anytime we have a y function, then we have to also include a dy by dx. Equals differentiating 2x squared, multiply by the power, take one off. Differentiating 15x, I think we just know that that's equal to 15, don't we? And then differential of 10y is going to be 10 dy by dx. So hopefully that hasn't caused you any problems. I want to get dy by dx equals, so all I now need to do is to get all the dy by dx's onto one side. I'm going to say 2y dy by dx minus 10 dy by dx is equal to 4x plus 15. Once I've done that, hopefully you've practiced these, so this should be like second nature to you. Take dy by dx as a factor, which is leaving me 2y minus 10 equals 4x plus 15. And so from that, dy by dx is going to be equal to, in this case, 4x plus 15 over 2y minus 10. Not unusual to have a dy by dx in terms of both x's and y's when we've got implicit differentiation there. Okay, part B. What does part B say? Part B says the curve is not defined for values of x in the interval between P and Q. So if we look at our graph here, yeah, look, I can see what's happening here. There's no values in between those two, okay, that they're asymptotes in effect. And what they're asking us to do is to say, what are the values of P and Q? Well, what I need to do is to look at the gradient at that point and the gradient at that point. Now, you'll be familiar with finding gradient when we have a minimum or a maximum. And with those ones, we say dy by dx is equal to 0 because we've got a flat gradient there. We've got a flat gradient, the gradient's equal to 0. Well, if we have a gradient that's straight up and down, then if we go a vertical gradient, then the gradient isn't equal to 0, the gradient's equal to infinity, okay? So if we look at that, let's just get rid of all that stuff. If I've got a situation with both P and Q, where I can say there, as far as I'm concerned, that gradient is equal to infinity, and the same here, that gradient would be equal to infinity for both of them. Let's go back and look at our gradient function. dy by dx is the gradient function. Well, how do I make this equal to infinity or undefined? How do I make it so that it doesn't exist? We want the bottom part to be equal to 0, don't we? Because we can't divide by 0. So that's quite a difficult thought process, but now how do I explain that to the examiner? I'd say for points P and Q, I'd say the gradient is equal to infinity, therefore 2y minus 10 must equal to 0. So if that's true, 2y minus 10 is equal to 0, y is equal to 5, and I want the actual points, what do I want, the x values of them, find the values of P and Q, and the values of P and Q are the x values here and here, aren't they? The x values there. So if I've got that y is equal to 5, what I need to do is go back to the original equation here now, set y equals 5, and when I set y equals 5, I'll end up with a quadratic in terms of x's. So if y, just remind yourself what the original equation was, y squared is 2x squared plus 15x plus 10y, but y is equal to 5, so we get 25 is equal to 2x squared plus 15x and plus 50 there. And then, as I say, I know now I'm going to have to solve this as a quadratic, so tidy this all up, make it equal to 0. 2x squared plus 15x plus 25 equals 0. Now, if you're not very strong with quadratics, just stick it into the quadratic formula. I'm pretty sure, given the nature of this question, this probably factorizes, so let's have a go at trying to do that. And again, you can do the slow quadratic factorization where this value is greater than 1. There's videos on the channel that show you how to do that. I'm not going to take any time over that. We haven't got time in the video here. This factorizes out to 2x plus 5, x plus 5. So this is going to give me x equals minus 5 over 2 from that one, or x equals minus 5 from that one. Again, not taking too much time over that, given that this is a P4 question. And going back, so when we're looking at these two, P is the furthest one to the left, isn't it? So we're going to get that P is equal to minus 5 and Q is equal to minus 5 over 2. So hopefully that all makes sense to you. That's probably one of the first times you've seen this situation here where we're actually looking a tangent, in effect, a tangent to a curve there. If it's parallel to the y-axis, the gradient of that line is y equals, isn't it? So the gradient of that line is equal to 0. Okay, so is equal to infinity. And if the gradient's equal to infinity, then you can put the denominator was equal to 0. Okay, hopefully that all makes sense to you.